On a gray November morning in 1995, Thomas Bradford stood at the edge of a construction site in Wilkes-Barre, Pennsylvania, and watched $340,000 worth of excavator sink deeper into the mud. The Caterpillar 330 had broken through what the soil engineers promised was stable ground 3 days earlier. The machine had dropped like a stone, its 66,000-pound weight punching through a thin crust of gravel fill into the soft clay and groundwater beneath. Now the excavator sat in what had become a mud pit, buried past its tracks, its cab tilted at a 15-degree angle, sinking another inch every few hours. Thomas was the project engineer for Bradford & Sons Construction, a third-generation company that had built half the commercial structures in northeastern Pennsylvania. He was a tall man, 6'1", with broad shoulders, a master's degree in civil engineering from Penn State, and 20 years of experience managing job sites. He wore a tan Carhartt jacket over a company polo shirt, Timberland boots that cost $200, and a yellow hard hat with Bradford and SONS project engineer, stenciled in black letters. He carried a clipboard with soil reports, recovery plans, and a growing list of failed attempts. Thomas had tried everything. On day one, he'd brought in 2 Caterpillar D8 bulldozers and chained them to the stuck excavator. The dozers had pulled until their own tracks started to slip, until the chains groaned and threatened to snap. The excavator hadn't moved an inch. On day 2, he'd called in a heavy recovery company from Scranton. They'd brought a modern Peterbilt rotator wrecker with a 75-ton boom and computerized hydraulics. They'd rigged it from every angle. The boom had extended to its maximum reach. The hydraulic winch had screamed. The outriggers had sunk 6 inches into the ground. The excavator stayed exactly where it was. On day 3, Thomas had hired a crane service. A 90-ton Grove mobile crane had arrived on a lowboy trailer, set up 200 feet from the pit, and attempted to lift. The crane operator had taken one look at the soft ground, shaken his head, and refused to get any closer. "That soil won't hold my stabilizers," he'd said. "You want 2 machines stuck instead of 1. Now Thomas stood with his site foreman, a man named Rick Paulson, and the owner of the excavator, a contractor named Dave Mitchell who was losing $3,500 a day in rental fees while his machine sat immobilized. "We need to bring in specialty equipment," Rick said. "There's a company in Harrisburg that does swamp recoveries. They've got mats, winches, the whole setup." "That'll cost $15,000 just to mobilize," Thomas said, running a hand over his face. "Plus whatever they charge for the actual recovery. We're already $22,000 into this between equipment rental and downtime. The client's going to have my head." "What's the alternative?" Dave Mitchell asked. His voice was tight. "That excavator's worth $340,000. Every day it sits there, I'm losing money and it's sinking deeper. The mud's already over the track frames. Give it another week and we'll never get it out." Thomas didn't have an answer. His engineering degree, his 2 decades of experience, his modern equipment and detailed soil reports, none of it had solved this problem. And everyone on this construction site was going to know it. That's when the 1948 Autocar U7144T came rumbling through the gate. Let me tell you about Stanley Kowalczyk, because you need to understand the man before you can understand what he did. Stanley was 76 years old in 1995, and he looked like a man carved from Pennsylvania coal country. He was short, 5'6", and built like a fire hydrant, all compact muscle and stubborn bone. His face was deeply creased, weathered by 76 winters and 45 years of outdoor work. He had thick white eyebrows that stuck out like wire brushes, pale blue eyes that missed nothing, and large rough hands that were permanently stained with grease and scarred from decades of mechanical work. Stanley wore the same outfit he'd worn since 1950, navy blue Dickies work pants held up with brown suspenders over a green and gray plaid flannel shirt, heavy steel-toed work boots with Vibram soles that he'd been resoling at the same cobbler for 30 years, and a brown canvas Filson work jacket that was so worn the waxed finish had turned to soft cloth. On his head, he wore a gray wool flat cap, an Irish style that his father had worn in the steel mills. Stanley had been in the recovery business since 1950, when he came back from Korea with a silver star and $2,200 in saved pay. He bought his first wrecker, a used 1948 Autocar U7144T, from a bankrupt towing company in Pittston for $650 and started Kowalczyk Heavy Recovery out of his uncle's garage. For 45 years, Stanley had pulled equipment out of impossible places. Coal trucks from strip mines, bulldozers from river bottoms, steel equipment from factory floors where overhead cranes had failed, locomotives from derailments. He'd done it all with the same truck, that 1948 Autocar, and with the same philosophy: physics beats power, patience beats speed, and the right rigging beats expensive equipment. The Autocar was ancient by 1995 standards. It had a Hercules DFXC straight-six diesel that made maybe 140 horsepower. It had a 5-speed crash gearbox that required double clutching. It had no power steering. Turning the wheel required both hands and genuine effort. The cab was open air with a canvas top. The seat was a spring-mounted bench with cracked leather covering. The paint, originally red and white, had faded to rust orange and cream, with patches of bare metal showing through. But the Autocar had something that modern wreckers didn't have. It had a custom-built recovery boom that Stanley's uncle, a master welder who'd worked in the Bethlehem steel shipyards, had fabricated in 1949. The boom used a compound pulley system with a 12-to-1 mechanical advantage, powered by a direct-drive winch that ran off the truck's transmission. It was slow, crude, and simple. It was also unstoppable. Stanley had retired in 1993. He'd sold Kowalczyk Heavy Recovery to a younger operator and moved to a small house in Mountain Top, but he'd kept the Autocar. He couldn't sell it. The truck had been his partner for 45 years. It had put his 3 daughters through college. It had built his life. When Stanley's neighbor, a steel worker who did side work for Bradford and Sons, mentioned the stuck excavator at the Wilkes-Barre site, Stanley had climbed into the Autocar, fired up the Hercules diesel, and driven the 18 miles to the construction site. Not because he'd been hired, not because he expected to be paid, but because he knew, the way a stone mason knows the strength of rock, that his 47-year-old wrecker could pull out what the modern equipment couldn't. Thomas Bradford watched the Autocar approach with a mixture of confusion and irritation. The truck looked like it had escaped from a museum or a junkyard. It was small, boxy, covered in rust and dents. The boom was a crude lattice of welded steel that looked homemade. The whole rig couldn't have weighed more than 15,000 pounds. Stanley stopped the Autocar near the edge of the mud pit. He climbed down slowly, 76-year-old knees and a bad back from Korea making the movement stiff, and walked toward where the 3 men stood. "Morning," Stanley said. His voice was gravelly, roughened by years of unfiltered Camel cigarettes he'd quit in 1978. Thomas looked at him, this short, elderly man in suspenders and a flat cap, and felt his irritation spike into something sharper. "This is a private construction site," Thomas said, adjusting his hard hat. "Insurance liability, OSHA regulations, you can't be here." "I know," Stanley said. "I've worked Pennsylvania construction sites since before you were born." His pale blue eyes flicked to Thomas's clipboard, to the soil reports and recovery plans. "Heard you've got an excavator stuck." "We've got it under control," Thomas said. Stanley looked past him at the Caterpillar 330, sunk to its cab in mud, tilted like a dying animal. He looked at the tracks the bulldozers had left, at the excavator tire prints from the failed crane setup. "Doesn't look under control," Stanley said. Thomas's jaw tightened. "We're bringing in specialty equipment. Swamp recovery specialists. They'll be here tomorrow. Tomorrow that machine'll be another 2 inches deeper," Stanley said. "And swamp recovery teams use the same principle I do, mechanical advantage and solid anchor points, except they'll charge you $20,000 for what I can do for free." "Free," Thomas repeated, his voice carrying an edge of condescension. "With that," he gestured at the Autocar. "Yes." Thomas looked at Rick. Rick shrugged. He looked at Dave Mitchell, whose face showed the desperate hope of a man watching his investment disappear into mud. "Him try," Dave said. "What have we got to lose?" Thomas pulled off his hard hat and ran a hand through his hair. His engineering degree from Penn State, his 20 years of experience, his detailed soil analysis and modern equipment, and now he was being told to step aside for an old man in a flat cap driving a truck that belonged in a scrapyard. Fine, Thomas said. But when that antique breaks down or gets stuck itself, you're getting it out of here on your own dime, Stanley nodded. Fair enough. Me tell you about mechanical advantage because it's the heart of this story. Most people think recovery work is about power, big engines, strong winches, heavy equipment. But Stanley Kowalczyk had learned in 1950 that recovery work is about physics. Specifically about mechanical advantage. Mechanical advantage is simple. It's using tools to multiply force. A lever lets you lift a heavy rock with less effort. A pulley lets you pull a load with less force. And when you combine multiple pulleys in a system called a block and tackle, you can multiply your pulling force exponentially. The modern wreckers that Thomas had brought in, the Peterbilt rotator, the bulldozers, they relied on raw power. Big hydraulic pumps, strong motors, heavy machines. But power alone doesn't work when the ground won't hold you. Those bulldozers had tracks that wanted to slip. That rotator had outriggers that sank into soft soil. That crane needed stable ground that didn't exist. Stanley's Autocar worked differently. It didn't need to be close to the stuck machine. It didn't need stable ground under its own wheels. It needed three things: a solid anchor point far from the mud, enough cable to reach, and the right rigging to multiply force. Stanley spent the first hour doing what Thomas hadn't done, finding anchor points. He walked the construction site, studying it with eyes that had seen 1,000 recovery situations. He found what he needed: a massive concrete footer that had been poured for the building's foundation, 150 feet from the mud pit. The footer was 4 feet thick, 12 feet wide, and extended 6 feet into bedrock. It wasn't going anywhere. He also found a second anchor point: a mature oak tree with a trunk 4 feet in diameter, another 100 feet in a different direction. The tree had been there for over a century. Its roots went down 20 feet into Pennsylvania clay. Thomas watched from the mud pit's edge, arms crossed, clipboard in hand, as Stanley paced distances and took measurements with a carpenter's tape measure. Rick stood next to him, curious now. Dave Mitchell watched with desperate hope. "What's he doing?" Thomas asked. "Looks like he's surveying," Rick said. "We already have surveys, we have soil reports, we have engineering data." "Think he cares about your reports," Rick said quietly. Stanley returned to the autocar and began unloading equipment. Not hydraulic tools, not power equipment. Just simple gear that looked like it belonged in a 1950s toolbox. Heavy steel snatch blocks, pulleys the size of truck wheels, massive lengths of thick steel cable, wooden cribbing blocks, heavy chains with links as thick as a man's thumb, and canvas bags full of shackles. "What is all that?" Thomas called out. "Physics," Stanley said. He carried 2 of the massive snatch blocks to the concrete footer. Each block weighed over 100 pounds, but Stanley moved them with the efficiency of long practice, his compact body built for this kind of work. He attached the first block to the footer using a steel cable wrapped around it 4 times, then secured with heavy shackles. Then he did something that made Thomas frown. Instead of pointing the cable directly at the stuck excavator, Stanley ran it at a 45-degree angle to the oak tree where he attached the second snatch block. "That's the wrong angle," Thomas said, walking over. "The pull needs to be straight. Any engineer knows that." Stanley looked at him with those pale blue eyes. "Any engineer who never pulled a stuck machine knows that. You pull straight, you're fighting all the resistance at once. You pull at an angle, you break the suction first, then redirect. 2 pulls instead of 1, but each pull is easier." He ran the cable from the oak tree's snatch block back toward the mud pit at another angle, where he set up a third snatch block anchored to a buried deadman. A steel beam he sunk 4 feet into the ground using a manual post hole digger and a sledgehammer. Thomas watched, his engineering mind starting to understand despite his irritation. "You're setting up a compound pulley system. 12-to-1 mechanical advantage," Stanley said. "Every pound of pull from my winch becomes 12 pounds of pull on that excavator, plus the angular pulls to break suction before the main extraction. That's going to take forever. A 12-to-1 system means you're pulling 12 times slower." Time's cheaper than a second stuck machine, Stanley said. He spent another 30 minutes rigging the cable path, from the Autocar's winch to the concrete footer's snatch block to the oak tree's block to the buried deadman's block, and finally down into the mud pit where he waded in, mud up to his thighs, his wool cap still firmly on his head, and attached the cable to the excavator's frame using heavy chains. By the time he climbed out of the mud, his Dickies pants were soaked and caked with clay, but his pale blue eyes showed satisfaction. Thomas, Rick, and Dave stood watching. A crowd had gathered, construction workers, the crane operator who'd refused to get close, even the bulldozer operators who'd failed on day one. Stanley climbed into the Autocar's cab, his compact frame fitting easily into the worn seat. He engaged the power takeoff that ran the winch and put the transmission in low gear. The cable went taut. The snatch blocks creaked. The oak tree groaned slightly. The concrete footer didn't move at all. It was anchored to bedrock. For a long moment, nothing seemed to happen. Then Thomas saw it, the mud around the excavator's left track shifting. Not much, just a tremor, but movement. Stanley kept the winch turning. The Hercules diesel chugged steadily, the direct drive winch multiplying the force 12 times over. The sound was different from modern hydraulic systems. No whine, no electronic hum, just the steady mechanical rhythm of gears and cable. The excavator's left side lifted a quarter inch, then half an inch. The suction that had held it for 3 days was breaking. The crowd went quiet. Stanley worked the Autocar's controls like a surgeon. Short pulls, pauses to let the mud settle, redirecting angles by repositioning his truck slightly. He wasn't forcing it. He was coaxing it. 10 minutes into the pull, the excavator's left track emerged from the mud with a sucking sound. The machine tilted further, but now it was tilting up instead of sinking. 20 minutes in, both tracks were visible. The excavator was rising, the compound pulley system dragging it out of the pit inch by inch. 37 minutes after Stanley started, the Caterpillar 330 was on solid ground. Mud-covered, tilted, but free. The construction site erupted. Workers were cheering, whistling, slapping each other on the backs. The bulldozer operators were shaking their heads in disbelief. Dave Mitchell looked like he might cry. Thomas Bradford stood absolutely still, his clipboard forgotten at his side, his engineering degree feeling hollow. Stanley shut off the Autocar's winch, climbed down, and began disconnecting his rigging with the same methodical patience he'd shown setting it up. Thomas walked over to him slowly. His Timberland boots squelched in the mud. "How?" Thomas said. Stanley coiled cable around his forearm, his scarred hands working automatically. "Told you, physics, mechanical advantage, solid anchor points, patience. We had more powerful equipment." "You had expensive equipment," Stanley corrected. "Not the same thing. That rotator's got 75 tons of lifting capacity, but lifting's not pulling. Those bulldozers are strong, but they need traction you don't have. That crane needs stable ground that doesn't exist." He secured the cable to the Autocar's boom. "I learned this in Korea. We get trucks stuck in mud that made this look like a parking lot. No cranes, no bulldozers, no hydraulics, just cable, pulleys, and anchor points. You learn real fast that the man who understands physics beats the man with the biggest machine." Thomas was quiet for a long time, watching this short, elderly man in mud-caked Dickies and suspenders load equipment that looked like it belonged in a museum. "What do I owe you?" Thomas asked finally. "Nothing," Stanley said. "Nothing. You just saved us $340,000. I did it because your neighbor asked me to look. I don't need money. I need young engineers to stop thinking their degrees mean they know everything." Thomas felt his face flush. "I never said." "You didn't have to say it. I saw it in your face when I drove up. Old man, old truck. What could he possibly know that a Penn State engineer doesn't?" Stanley's pale blue eyes held Thomas's gaze. "You know what your problem was. You looked at that stuck excavator and saw a crane problem, or a bulldozer problem, or a specialty equipment problem. You never once looked at it as a physics problem." He climbed into the Autocar's cab, started the Hercules diesel, and drove toward the gate. Thomas stood there in the mud, watching him go, feeling like he'd just been educated by his grandfather. Let me tell you what happened over the next 6 months, because this story doesn't end at that construction site. Thomas Bradford went home that night and couldn't stop thinking about what he'd seen. A 76-year-old man in a 47-year-old truck had solved a problem that defeated modern engineering. Not through power, not through technology, through understanding. The next week, Thomas drove to Mountain Top and knocked on Stanley Kowalczyk's door. Stanley answered wearing the same suspenders and flannel shirt. "Wondered when you'd show up," he said. "How did you know I would?" "Because you're not stupid. Arrogant maybe, but not stupid." Thomas followed Stanley to a workshop behind his house. The walls were lined with tools, old tools, hand tools, carefully maintained and organized. There were no power tools except a drill press from the 1960s and a welding machine. "Teach me," Thomas said. Stanley looked at him for a long moment. "You're a project engineer. You make good money. You've got degrees. Why do you want to learn from an old man?" "Because everything I know came from books and computers," Thomas said. "And a 76-year-old man with a tape measure and a notebook just showed me I don't understand the most basic thing, how to actually move heavy objects in the real world." Stanley smiled slightly. "All right, but you do what I say. No arguing. No, but my engineering textbook says. You want to learn how things really work, you learn my way." Thomas came to Stanley's workshop every Saturday for 6 months. Stanley taught him mechanical advantage, rigging angles, load distribution, soil mechanics that no textbook covered. He taught him to read ground conditions by walking on them, to understand failure points by looking at equipment, to calculate forces in his head instead of relying on software. But more than that, Stanley taught him humility. He taught him that the newest solution wasn't always the best solution. That sometimes the old ways worked better because they'd been refined through decades of actual use instead of theoretical modeling. Thomas started applying what he learned. When Bradford and Sons construction hit problems on job sites, Thomas would stop and think like Stanley. What are the anchor points? What's the mechanical advantage? What does the ground tell me? His success rate improved. His equipment costs went down. His reputation grew. In 1997, Bradford and Sons was hired for a bridge demolition project over the Susquehanna River. A section of the old bridge needed to be lowered into the water in one piece, 65 tons of steel and concrete. A controlled descent that engineers said required a $150,000 crane setup. Thomas looked at the bridge, looked at the anchor points, and designed a rigging system using mechanical advantage that cost $8,000 in equipment rental. He called Stanley to review his plans. Stanley studied the drawings, made 2 small corrections, and nodded. "You're learning." The bridge section came down perfectly. The client saved $142,000. And Thomas Bradford put a line in his project proposal that made his company different from every other contractor in Pennsylvania. Traditional engineering combined with old-school rigging expertise. Kowalczyk died in 2001 at the age of 82. His funeral was held at St. Stanislaus Church in Pittston, and over 500 people came. Construction workers, tow operators, engineers, people whose equipment he'd saved over 45 years. Thomas Bradford gave the eulogy. "Stanley taught me something my engineering degree never did," Thomas said from the pulpit. "He taught me that the best solution isn't always the most expensive one, that understanding beats technology, that patience beats power, and that a man who learned his trade by doing it for 45 years knows things that no textbook can teach." At the burial, Thomas had arranged for the 1948 Autocar to be driven to the cemetery. It sat at the edge of the grave site, its cable extended, a symbol of a man who'd spent his life pulling people out of impossible situations. After the funeral, Thomas bought the Autocar from Stanley's daughters. Not to use regularly, though he did use it occasionally, but to keep it as a reminder. He restored it completely, painted it in Stanley's original red and white, and put KOWALCZYK Memorial EST 1950 on the door. The truck sits in Bradford and Sons equipment yard in Wilkes-Barre under a covered shelter, and when young engineers join the company, Thomas takes them to see it. "This truck is worth more than any degree," he tells them, "because it represents something you won't learn in school, that the oldest tool, used correctly, can outperform the newest technology, That understanding physics beats throwing money at problems, and that humility is the foundation of true expertise. 1948 Autocar U7144T still runs. Thomas starts it once a month, drives it around the yard, checks the rigging, and occasionally, when a job comes up that modern equipment can't handle, he'll fire up that Hercules diesel and prove once again that Stanley Kowalczyk's principles still work, because engineers still think technology solves everything. Construction sites still have problems that defeat expensive equipment. And every few years, someone needs to learn what Thomas learned in 1995. The old ways aren't obsolete. They're foundational. And sometimes the man who knows how to use a 47-year-old truck teaches you more than 4 years at Penn State ever could.